Introduction. Students, look at these numbers. These are the whole numbers. Now look at these numbers. These are the negative numbers. But what do we call a bigger collection of numbers which contains whole numbers and negative numbers? Those numbers are called integers. Come, let's learn more about integers. Objectives. At the end of this lesson, you will be able to define integers, write the properties of integers, and write the operations on integers. Students, what do we get if we add two integers? Let us see. Rohan has 6 balls. His friend Sohan has 5 balls. So how many balls are there in total? Yes, 11 balls in total. From this example we can say that addition of two integers is also an integer. We can see that addition of integers gives integers. So, integers are closed under addition. Look at Reena. She has 5 chocolates. If she gives 3 chocolates to her brother, then how many chocolates are left with Reena? Yes, you're right. She is left with 2 chocolates. In this example we see that difference of two integers is also an integer. Hence, integers are closed under subtraction. In general, for any two integers a and b, a plus b is an integer. Similarly, if a and b are two integers, then a minus b is also an integer. Let's now move towards another property, that is commutative property. This is a 10 rupee note. If we add one coin of 2 rupees in it, we will get 12 rupees. Now take a coin of 2 rupee and add one note of 10 rupee in it. Again, we will get 12 rupees. Or we can write it as 10 plus 2 is equal to 12. And 2 plus 10 equals 12. In both the cases, we get the same answer. This means the integers can be added in any manner. Hence, addition is commutative for integers. In general, for any two integers a and b, we can say a plus b is equal to b plus a.
Associative property. So far, we have studied the closure property and the commutative property. We will now learn one more property, called associative property. For this, consider a situation where Peter and Sam have some red, yellow, and green-colored balls. They want to find out the total number of balls that they are having. Let us see how they did this. Peter first adds the number of red and yellow balls, and gets a sum of 5 balls. He then adds the number of green balls, that is, 4, to the sum 5, and gets a total of 9 balls. Now Sam first adds the number of yellow and green balls, and gets a sum of 7 balls. He then adds the number of red balls, that is, 2, to the sum 7, and gets a total of 9 balls. Observe that, here, Peter and Sam have added the numbers by 2 different ways, but obtained the same total. So, we can say that 2 plus 3 plus 4 is equal to 2 plus 3 plus 4. Let us verify this result with 3 other numbers, say 4, 6, and 8. On adding 4 and 6, we get 10. Now adding 8 to this sum, we get 18. Let us add these numbers in a different order, that is, first add 6 and 8 to get 14. Then add 4 to this sum to get 18. Hence, 4 plus 6 plus 8 is equal to 4 plus 6 plus 8. In general, we can state that A plus B plus C is equal to A plus B plus C. This is called associativity.